Hello everyone. We start with the first lecture of Module 1 where we will discuss the basics of communication system and its classification. Let us start by answering a simple question. What is electronic communication? Electronic communication basically refers to conveying of information from one geographical location to another using electronic circuits, or we can define it as transmission, reception, and processing of information between two or more geographical locations using electronic circuits. Now, as we said, information is conveyed. What do you mean by information? Basically, it means what we want to transmit. The common types of information that humans tend to transmit is of the form like text, video, image, speech, music, or data generated from a computer system. These forms of information, when needs to be transmitted over long distances, will have to be converted into an electrical signal before it can be processed and made suitable for transmission using electronic communication system. We can convert these forms of information into an electrical signal using a transducer. The output of a transducer will be an electrical signal, which will tend to occupy a fixed frequency range, typically ranging from 0 Hz to a few kilohertz or megahertz, depending upon the type of information. Example, speech occupies a frequency range from 0 to 4 kilohertz. Music occupies a frequency from 0 to 15 kilohertz, while video from 0 to 5 megahertz. These signals so generated, which occupies frequency from 0 hertz to some value in hertz, kilohertz or megahertz, are called as baseband signals. And the bandwidth they occupy is called as signal bandwidth. So we know that bandwidth is defined as the range of frequencies that the signal occupies, and it is calculated by subtracting the lowest frequency component present in the signal from the highest frequency component. So we can say that speech has a signal bandwidth of 4 kilohertz minus 0 hertz, which is equal to 4 kilohertz. Music has a signal bandwidth of 15 kilohertz minus 0, which is 15 kilohertz. Right? So now, before we start with the classification of communication systems, let us take a quick look at the history of communication systems. Humans always had a need to communicate. Initially, they used semaphores, that is waving of the flags, smoke signals, or human messengers to send messages over long distances. The first communication system, the electrical communication systems that came into existence, was telegraphy, which worked using Morse codes. Morse codes uses a series or a combination of on and off signals to represent information. It required human intervention to send these on and off signals and receive and record these signals to be finally deciphered by looking at a combination of signals and referring to a chart. One of the major revolutions in the field of electronic communication systems came with the invention of telephony, which allowed voice to be transmitted over longer distances. Later came in radio broadcasting, which allowed voice and music transmission, followed by television broadcasting, which also enabled video transmission. Another milestone was achieved when satellite communication systems were developed. It enabled global communication, though satellites find use in many other applications other than mere communication. And the most popular and latest one, no doubt, is cellular communication or mobile telephony. Though systems existed for voice, music, and video transmission, people wanted mobility and portability as a convenience. Cellular communication system, which started in the early 1990s in itself, has evolved through its generations. 1G and 2G supported voice communication and transmission of short messages, that is SMS. The difference between 1G and 2G being 1G was analog system while 2G was a digital system. People wanted more features, so came 2.5G, which supported data rate of a few kbps and supported web browsing to a certain extent, MMS, etc. With this started the wave to increase the data handling capability and came in 3G, which supported high-speed internet connectivity, multimedia content transfer, real-time applications, etc. at about 1 Mbps. Then came in 4G and now 5G, which offer much enhanced features and support much higher data rates. So this journey from 2.5G to present 5G is all about improving the data rate so that much more enhanced real-time applications can be supported. So these are the few significant communication systems that have evolved. What I want to emphasize here is though each one is developed for a certain set of applications, the fundamental concepts and principle of working is essentially the same. It is the technology to implement these concepts that have developed, that have evolved, that has changed. And in this subject, our focus is to study these fundamental concepts and techniques. So with this, now we look at the classification of electronic communication systems. Communication systems can be broadly classified on the basis of 4 parameters: transmission modes, type of signals, type of channel, and transmission method. On the basis of transmission mode, communication systems can be classified as simplex, half duplex, and full duplex. In case of simplex mode of communication, transmission is allowed in one direction only. One station acts as a transmitter and the other as a receiver. Common examples include radio and television broadcasting systems. In case of half duplex mode, transmission is allowed in either direction but one at a time. If station A is transmitting, B is receiving. But at any other time, B can transmit and A can receive. That is, both stations have the capability to transmit as well as receive, but not simultaneously. The most popular example here is a walkie-talkie. Now, in full duplex mode, transmission can take place in both directions simultaneously. Both station A and B can simultaneously transmit as well as receive, and the most common example is telephony, both landline and mobile telephony. The next classification is on the basis of type of signal. The signal is referred to as the transmission of information in electrical or electromagnetic form. Typically, an electromagnetic signal is a function of time, but it can be expressed as a function of frequency as well. The signal can be either analog or it can be digital in nature. Analog signals are the ones in which the amplitude varies continuously with respect to time. Representation of an electromagnetic wave as a sinusoidal signal is an example of an analog signal. All of us understand that. And we also know that most of the transducers produce analog signal, though there are transducers which directly give us a digital output as well these days. Digital signals are represented in terms of zeros and ones, example being computer data. And please understand that analog data can be converted to a digital data using a device called as an analog to digital converter. So if a communication system transmits the information in an analog format, the system is said to be an analog communication system. And if the communication system transmits data in digital format, it is said to be a digital communication system. In the subsequent lectures, we will study the analog and digital communication system in detail, analyze the advantages and limitations of each of these, and compare them. Communication channel provides a means of carrying the electromagnetic signal between the transmitter and receiver. So channel is nothing but what links the transmitter to the receiver. On the basis of type of channel, communication systems can be classified as wireline or wireless. If there is a physical medium that connects the transmitter and the receiver, the channel is said to be wired or wireline or guided, and the communication system is then referred to as wired communication system. The typical physical medium to result into a wired communication system includes a twisted pair or a coaxial cable or an optical fiber cable. These are all examples of wired or guided channels. If the signal travels in free space, that is, the signal are radiated in free space using an antenna and then they are allowed to propagate in free space, the communication is said to be wireless. The examples being cellular telephony or radio transmission or satellite communication, they all work in wireless mode. So we will cover the types of channel in detail in the subsequent lecture. Lastly, we classify communication system based on the transmission method. It can be subclassified as baseband communication system and bandpass or broadband communication system. Now we know that typically information that needs to be transmitted can be either text or speech or image or video, etc. These are to be converted into an electrical signal using transducers. The signal generated at the output of the transistor occupy a certain frequency range as we discussed it a few minutes before. So say speech occupies a frequency range of 0 to 4 kilohertz and music 0 to 15 kilohertz. These are low frequency signals. And these signals are what we call them as baseband signals. These can be transmitted over copper wire or a twisted pair cable. And if that is the signal frequency that is being transmitted directly over a communication system, such communication systems are called as baseband communication systems. However, baseband communication systems allow only short distance communication. Also, such signals cannot be transmitted wirelessly. Now let me give you an analogy before I explain you what is bandpass or broadband communication. Say I want to go from Mumbai to Pune. Possibly I cannot walk, right? In a normal scenario. But I would use some form of transport. Maybe I'll take a bus or a train or I'll drive in a car. Some form of carrier, some form of transport is what I will need to travel from Mumbai to Pune. Similarly, a low frequency signal cannot travel long distances, cannot be used for long distance communication. We will need a carrier. We will need to superimpose this low frequency baseband signal onto a carrier that can carry it over long distances. This carrier here is nothing but a high frequency, constant amplitude signal. This process of superimposing a low frequency baseband signal onto a high frequency carrier signal is called as modulation. The resultant modulated signal is a high frequency signal that occupies a range of frequencies, and this signal is called as a bandpass or a broadband signal, and the communication systems that support modulation are termed as bandpass communication systems. We shall be covering various modulation techniques in subsequent lectures. Right? So with this is the broad classification of electronic communication systems. In the next lecture, we will be discussing types of channel in detail. Thank you.